Hey there. Tonight we drift together toward a telescope that doesn't just look at the stars. It stares into the beginning of everything. The James Webb Space Telescope floats in the black quiet, a golden eye open wider than any we've ever made. You imagine it above you now, its mirror glinting softly, each hexagon a petal of light suspended a million miles away. You could almost reach up and touch it if you didn't instantly freeze. Of course, you probably wouldn't survive that little stroll through space. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, let me know where you're listening from and what time it is for you right now. I love seeing how far this dreamy little community reaches. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You float weightlessly in the velvet dark. Before you, the James Webb Space Telescope spreads its gleaming wings, a mosaic of 18 hexagonal mirrors, each coated in pure gold so thin you could press hundreds of layers between your fingers and still not feel it. The mirror isn't just reflective, it's perfection polished to atomic precision. Each segment, made of beryllium, expands and contracts with space's chill, and Webb's engineers adjusted them to align to within a fraction of a wavelength of light. Imagine that a mirror so perfect it could spot a bumblebee on the moon. Not that it would bother. It's far too busy watching galaxies being born. The gold isn't just for show. In the infrared world, where JWST lives, gold reflects heat and light with uncanny efficiency. While your phone camera works in visible light, Webb's golden eye sees in the invisible heat signatures from ancient stars and baby planets still wrapped in dusty cocoons. Those warm tones you see in its famous photos, they're the universe's heat prints, stretched by time until even light becomes ancient. The telescope's shape is unmistakable, like a flower blooming endlessly in the dark. You can picture the unfolding, a ballet of mechanical precision lasting 2 nerve-wracking weeks after launch. Engineers back on Earth held their breath while Webb unfolded itself, petal by petal, screw by screw, over 1 million kilometers from home. They couldn't fix it if something went wrong. There was no second chance. No turn it off and back on again. You think about that, how humanity placed its most ambitious creation in a place no one could ever reach. It's equal parts brilliance and madness. A little like sending your most fragile treasure into the void and saying, "Please don't die." The primary mirror, that gold honeycomb disc, is 6.5 meters across, almost 3 times the diameter of Hubble's. Yet, it's lighter. The trick lies in its material. Beryllium. Strong, yet feather-light. Able to survive both launch vibrations and the cold breath of space. Each segment can move independently, adjusting itself like a musician tuning an instrument. The result? A symphony of photons gathered from the edge of time. A mainstream fact here: JWST's mirror gathers 6 times more light than Hubble's. That's not just a statistic, it's a time machine upgrade. Every extra photon means another sliver of the past revealed. With it, Webb can see galaxies so faint their light left before Earth even formed. And here's a more offbeat truth. The gold layer on all those mirror segments amounts to less than a golf ball's worth of metal. One tiny sphere of gold, vaporized, spread across 25 square meters. Humanity's priciest bling. But for once, fashion met physics. As you drift closer, the honeycomb glints like a sleeping eye catching starlight. The reflections shift across each facet, merging into one perfect focus point. Scientists still argue whether calling JWST a telescope does it justice. It's more like a time harp, strumming ancient light into meaning. A mirror that doesn't just reflect, it translates. You imagine yourself standing before that mirror, seeing not your own face, but the glow of the early universe shimmering back. Galaxies like smudges of candlelight. Stars flickering like embers under cosmic ash. And in that reflection, maybe, just maybe, a glimpse of where everything began. Engineers had to solve problems that sound absurd. How to keep a mirror this large aligned, while it floats freely in a vacuum, colder than anything you can imagine. They designed actuators, tiny motors thinner than a hair, that adjust each segment by nanometers. That's a few atoms width. Move it wrong, and you don't just blur an image, you lose the past. Some call Webb the golden eye of humanity. Others think of it as a mirror, held up to the cosmos itself. It doesn't just look outward, it reflects our craving to understand. But let's not get too romantic. This thing is an engineering nightmare wrapped in gold leaf. During its construction, every vibration, every temperature shift, every speck of dust mattered. Even a sneeze in the clean room could spell disaster. One engineer joked that it's like trying to fold a cathedral into a rocket fairing. Still, they did it. The mirror survived the ride, the unfolding, the alignment. And when Webb first opened its eye and saw starlight, just one perfect star for calibration, the entire world exhaled. People cried over a pinpoint of light. Imagine that. Billions of dollars, 2 decades of planning, and the triumph is a single pixel in the dark. You can picture the scientists huddled over their monitors, silent, staring. The first image appeared a sharp star against nothing. Proof that everything, every bolt, every fold had worked. Somewhere, someone whispered, "We did it." And that's when the golden mirror became more than metal. It became memory, a monument to persistence. You hover there now, close enough to feel the illusion of warmth radiating from that cold perfection. JWST doesn't hum or blink. It simply exists, patient, unblinking, drinking light from a universe older than imagination. You think about how strange it is. This machine can see the beginning of everything, but can't see itself. Its golden face is turned eternally outward, never homeward. The mirror, like us, is curious and lonely all at once. You drift closer to the shining gold mosaic until the scene shifts suddenly. Everything around you feels colder. The light softens, and even your thoughts seem to slow, thickening like syrup in the deep vacuum. You've reached the chill of infinity, the place where JWST keeps its heart frozen so it can see the faintest heat in the universe. The telescope's instruments operate near absolute zero, about 233 degrees Celsius. That's colder than Pluto's night, colder than dry ice, colder than any place you could survive for even a blink. Yet this frigid stillness isn't lifeless, it's clarity. Without that cold, JWST's own heat would blind its vision. Imagine trying to spot a candle from 1,000,000 miles away while staring into your own campfire. That's what infrared light does, it picks up warmth. And if JWST weren't freezing, all it would ever see is itself. So NASA gave it the gift of silence, the silence of deep cold. Its instruments are wrapped in layers of shielding, polished and tensioned, to keep sunlight, earthlight, and moonlight out. Every photon that isn't ancient starlight is the enemy. The telescope's backside, the one facing the sun, is hotter than boiling water, but flip it over to the mirror side, and it's colder than liquid nitrogen, just a few meters apart. The two faces exist in thermal contradiction fire and ice sharing a single body. You float closer, and you can almost feel that sharp drop in temperature. The atoms of your imagination slow to a crawl. Space has no air, no wind, no sound. But if silence had texture, this would be it. A mainstream fact slides through your mind like a frozen whisper. JWST uses a cryocooler, a refrigerator, the size of a small car, to keep one of its instruments, MIRI, at an even lower temperature, around 266 C. That's only a few degrees above absolute zero, where motion itself almost stops. MIRI is the telescope's mid-infrared eye, and it's so sensitive that the heat from a single human hand, a kilometer away, could ruin an observation, which is exactly why you're staying right here, ghost-like, watching from the dark. You imagine the cryocooler as a sleeping heart, pulsing not with blood, but with helium gas. The gas compresses, expands, cools, and repeats a mechanical sigh in slow motion. It's one of the coldest continuous mechanical operations ever achieved. The engineers who built it compared it to balancing a feather on a running chainsaw. Everything must hum in perfect rhythm, or the delicate balance collapses. And here's the quirky tidbit. Even though it's one of humanity's most precise machines, JWST isn't entirely immune to heat. Tiny micrometeoroids sometimes strike its mirror segments, leaving minute dents. Each time, engineers back on Earth tweak the mirror alignment to compensate. It's cosmic plastic surgery touch-ups for a golden giant 1.5 million kilometers away. You drift below, beneath the mirror, to where the instrument module lives. The area is packed with sensors and electronics, all cooled and shielded. In this icy realm, everything moves slow and sure. Even photons seem to tiptoe. And yet, despite the stillness, there's constant invisible motion. Signals streaming across deep space radio bands, sending terabytes of data back to Earth every day. JWST speaks in microwaves, whispering its discoveries to a handful of dishes on our planet's surface. Those antennas, scattered across continents, catch the faint murmur of its transmissions like cosmic lullabies. Some scientists still argue whether this constant communication adds subtle warmth to JWST's frame. Could radio chatter heat its circuits just enough to affect precision? The debate is ongoing, and the answer probably changes with every calibration. Even perfection, it turns out, has arguments in its sleep. You look out past the telescope into the black. Nothing glows except JWST's faint gold shimmer and the faraway gleam of stars. It feels timeless, this cold. You start to wonder what temperature thought might have, if stillness itself can freeze curiosity. And yet, here it is, curiosity running colder than any object we've ever built, and still burning bright. There's something eerie about the telescope's silence. If you could place your ear against it, not that sound travels here, you might imagine hearing the faint creak of contracting metal, like a sigh across the centuries. JWST breathes through thermal expansion and contraction. When it warms by a single degree, its entire frame shifts just a few nanometers. That's smaller than a virus. Yet for this telescope, it's significant enough to refocus its vision. You picture the engineers back home, sipping coffee in a climate-controlled lab, while their golden child floats in near absolute zero, half a galaxy away. They stare at numbers on screens, measuring vibrations that never happen, temperatures that never rise. They know the telescope's every whisper, every flicker. To them, JWST is alive not with thought, but with precision. You can almost feel its purpose vibrating through the void. The instruments, NIRCam, NIRSpec, MIRI, and NIRISol, tuned to catch specific shades of infrared light. Each one sees a slightly different universe, like layers of dreams stacked on top of each other. In NIRCam's dream, there are newborn stars hidden in dusty nurseries, glowing faintly through their veils. In NIRSpec's dream, whole galaxies spill their spectra, telling what they're made of and how fast they're fleeing from us. And in MIRI's coldest dream, ancient light flickers radiation stretched thin by billions of years of cosmic expansion. You realize something strange. JWST doesn't see colors the way you do. Its images start as invisible data streams of numbers, representing wavelengths beyond human vision. The breathtaking photos you've seen, with purples, reds, and blues, those are translations, interpretations. The real Webb sees a heat map of the universe. It's like describing a symphony to someone who can't hear, but can feel the vibrations. And that's where you smile. Because even in this frozen silence, there's creativity. The telescope gathers light we can't see and turns it into beauty we can't ignore. A stray thought drifts by. If heat is life, then JWST is the coldest living thing we've ever made. But life doesn't always need warmth. Sometimes it needs stillness. The telescope's quiet is what lets it listen to the universe's oldest whispers. You picture one last thing before moving on. JWST hanging there in the infinite dark, its cold side staring into time itself. And somewhere back on Earth, in warm rooms filled with glowing screens, humans lean in closer, trying to understand what it's saying. The cold connects them. The cold makes it possible. The chill of infinity is the price of knowing. You drift beneath the telescope now, the light shifting into a dim, silvery shimmer. The scene grows wider, like unfolding fabric beneath a lantern. There below, the gleaming gold mirror spreads the sunshield, JWST's most underrated miracle. You could mistake it for a vast metallic sail, delicate as tinfoil and bigger than a tennis court. It looks almost playful, like something meant to catch sunlight. But its purpose is the opposite. It hides from it. 5 razor-thin layers of kapton, stretched tighter than drum skin, protect the telescope from the sun's merciless glare. The top layer reflects and scatters light. The others step the heat down like cosmic insulation, from 100 C on one side to 233 C on the other. The difference between the two faces is more extreme than any desert night you could imagine. On one side, eternal day. On the other, eternal shadow. JWST lives on the edge between them, thriving in the balance. You float alongside that shimmering silver canopy. Each wrinkle, each seam, tells a story of tension and terror. Engineers called it the origami of doom, and for good reason. The sunshield had to unfold in space from 178 latches, 107 membrane release devices, and 140 pins, each one essential, each one ready to ruin 2 decades of work if it failed. For 14 days after launch, humanity collectively held its breath while the telescope unfolded like a cosmic butterfly, millimeter by millimeter. The mainstream fact comes quietly. The sunshield blocks more than 200,000 times the amount of heat energy that would otherwise hit the telescope's instruments. Without it, JWST's infrared sensors would saturate instantly. The shield doesn't just keep things cold, it creates a stable pocket of stillness, a permanent nighttime where the universe can whisper its oldest secrets. You stare at the sunshield and realize it's less like a barrier and more like a promise, that even in light, there can be dark places made safe for seeing. A breeze wouldn't flutter here, but you imagine one anyway. The soundless ripple of its 5 translucent layers, each thinner than a human hair yet strong enough to survive micrometeoroids traveling faster than bullets. One engineer once joked that JWST is the world's most expensive camping tent, except this one keeps out the sun instead of the rain. And yet, despite all that precision, there's a touch of chaos baked in. The Kapton material expands and contracts with every temperature shift, flexing unpredictably. Scientists still argue whether these microscopic movements create thermal noise, tiny changes that might blur images over time. So far, the data say it's fine, but space loves a good argument. You picture yourself floating above the silver canopy. From here, it looks like a silver sea, rippling softly with starlight. On the other side, the side facing the sun, everything burns invisible. You can almost feel the radiation beating down, desperate to reach the mirror but forever blocked by that shield. The telescope survives by hiding. The irony isn't lost on you. Humanity's greatest window to the cosmos works because it built a perfect umbrella. Below you, in the shadows, the instruments hum faintly, working through the darkness like night gardeners tending invisible flowers. The shield's 5 layers don't touch. They're separated by tiny gaps of vacuum, each one radiating heat away into the black. It's a miracle of physics, a kind of passive air conditioning that never runs out of coolant. Here's a curious detail you might like. JWST's sunshield isn't symmetrical. The layers taper toward the edges, and each one has tiny holes laser cut into it to prevent trapped air during launch. Every fold, every corner, was hand-checked, ironed flat, and inspected for even microscopic tears. Some engineers described it as wrapping a cathedral in tissue paper and then throwing it into a hurricane. It's not all cold sterility, though. There's poetry here, too. The shield's silvery surface reflects sunlight in slow, fluid patterns, like liquid mercury spreading through the void. And in that shifting sheen, you can almost see echoes of Earth, the faint outline of clouds, oceans, continents reflected in distorted silver. It's a quiet reminder of home, cast across something utterly alien. You imagine being one of the engineers watching from the control room during deployment. Days of nerve-fraying silence, broken only by telemetry updates. Layer 1 tensioned, Layer 2, Layer 3. Each update, another heartbeat, closer to triumph or disaster. One missed command could tangle the membranes beyond recovery. No astronaut could fix it. No rescue mission would come. Everything depended on folded plastic, wires, and faith. And yet, against the odds, it unfolded flawlessly. Humanity watched 1,000,000 kilometers away through a live data stream, cheering over dots on a screen. The relief was immense tears, laughter, disbelief. A lifetime of anxiety dissolved into joy. Now that sail floats effortlessly, doing its silent job, day after day. It doesn't need maintenance, doesn't need sleep. Just like the mirror above it, it simply endures gracefully, quietly, perfectly. And in that endurance, you find something comforting. The idea that fragility can coexist with strength, that thin films and fine lines can hold back the fury of the sun itself. A soft thought flickers by. Maybe that's what all of us are doing, in our own way, stretching out fragile layers to keep the harshness out, while we try to see something beautiful. The sunshield hums gently in your imagination. The silver layers seem to shimmer with a rhythm, almost like breathing. You let yourself drift with it, in and out, matching its pace. Each exhale, a bit of light. Each inhale, a bit of dark. Somewhere behind you, Earth turns slowly, blue and distant. JWST keeps its back to it, focused only forward towards stars, so ancient they shine with light that's older than the oceans. This sail of silver, this great cosmic parasol, will keep protecting that gaze for decades, until fuel runs out and gravity reclaims the machine. When that day comes, the shield will still glimmer for a while, long after its mind goes quiet. A silver leaf floating in endless dark. You wonder, almost sleepily now, how many secrets the sunshield has already caught light bent through its edge. Faint reflections of worlds unseen. You'll never know. JWST keeps its mysteries well hidden behind 5 layers of silence. Still, you smile. Somewhere, on that silver skin, sunlight touches human ingenuity and turns into shadow, so the universe can glow. The silver glow fades, and for a moment, everything feels weightless, utterly still, until a new motion carries you forward. The telescope drifts onward, a golden kite gliding through gravitational twilight. This is the journey to L2, the strange and perfect place where JWST lives, balanced not by fuel or engines, but by math, light, and luck. You trail behind it, watching its slow, silent migration. After launch, the telescope didn't orbit Earth like Hubble. No, it left home behind. It sailed out nearly 1.5 million kilometers into the dark, to a spot called the second Lagrange point, or L2, a gravitational sweet spot, where the forces of Earth and Sun tug just enough to let an object hover in place. It's like the calm center of 2 invisible tides, where the pull of gravity and the push of orbital momentum cancel each other out. You imagine this region as a cosmic hammocker, cradle of equilibrium suspended between 2 celestial giants. The telescope floats there, not stationary exactly, but looping around that balance point in a lazy halo orbit. The size of the moon's distance divided by 10. It doesn't take much effort to stay just small puffs of fuel every few weeks, a little nudge to keep it centered in the dance. It's poetic, really. JWST doesn't fight gravity. It cooperates with it. A mainstream fact drifts into the thought. There are 5 of these special points between Earth and Sun L. 1 through L. 5. Each one a delicate gravitational compromise. L2 is the favorite for deep space observatories because it keeps the Earth, Moon, and Sun all on the same side. That means JWST's sunshield can face all 3 at once, blocking their warmth while the mirror stares into unbroken darkness. The telescope's trip to this spot wasn't quick. After launch, it coasted for nearly a month, traveling at speeds up to 33,000 kilometers per hour, before slowing to a graceful stop in its orbital perch. You can imagine it gold unfolding, silver blooming, drifting farther and farther from Earth, until home became just a pale blue speck. Every kilometer of that journey had to be perfect. There was no second burn, no turning around. It's humbling to think JWST can never come home. It's too far for repair missions, too delicate for retrieval. Its voyage was one way, its exile permanent. It's humanity's most expensive ghost ship, forever orbiting a mathematical point in space. You watch it from afar now, tracing its motion in slow arcs. The background stars remain motionless, but JWST drifts in a subtle ellipse, its halo orbit around L2. The entire path is stable yet dynamic, a perfect paradox. Here's a quirky tidbit. If you were standing at L2 and looked toward the Sun, you'd see Earth as a tiny dark disk with a bright blue ring of atmosphere. That glowing ring sunlight filtered through oceans, clouds, and life would shimmer faintly against the black. JWST sees that view constantly, though it never turns its gaze toward home. Its mirror always faces away, loyal to the deep. There's something haunting in that. The telescope sits forever in Earth's shadow, orbiting a point that isn't even a thing, just a solution to an equation. It doesn't orbit a planet or a star. It orbits an idea. Scientists still argue whether L2 should be considered truly stable. The gravitational balance isn't perfect. It wobbles. Without regular course corrections, JWST would drift away within weeks. That fragility makes its precision all the more impressive. A constant dance of adjustments to stay right where the universe wants it. You can almost hear the tiny thrusters firing short, quiet bursts of nitrogen gas nudging the telescope's path. No flames, no roar, just soft puffs of motion in the vacuum. Each burn lasts only seconds, but keeps JWST from slipping out of its invisible cradle. In that sense, the telescope is always falling, but never landing. You imagine being on board, looking out from a maintenance hatch that doesn't exist. Ahead, there's nothing but the black sea of the cosmos. Behind, the sun hides behind its silver sail. The Earth is a jewel you can't see, though you know it's there always on the other side of the shield, glowing faintly through the folds of time and distance. It's peaceful here. You start to feel the pull of that serenity, as though your thoughts themselves might settle into orbit around this balance point. JWST's instruments awaken, each one calibrating to the steady light of stars. The temperature stabilizes, the vibrations fade, and data begins to stream homeward. The journey is over, but the mission has just begun. A fragment of an engineer's diary comes to mind, a line spoken softly during the mission's success broadcast. We sent a telescope to a gravitational ghost, and it found its footing. You smile at the thought. L2 might not be a physical place, but it feels like one. Now a quiet perch, where a golden eye keeps watch, orbiting not a world, but wonder itself. There's an irony in all of this. We humans build telescopes to seek out planets, yet we send them to places where none exist. We chase stability by leaving everything stable behind. The telescope's steady hum continues, the whisper of data flowing through deep space. It feels alive, though its heart beats in mathematics, not muscle. You notice something else as you float nearby. The light from distant stars bends slightly around the telescope's frame. It's an optical illusion, but it feels meaningful. The mirror catching photons, the shield reflecting radiation, the orbit balancing gravity. It's all one grand equation, a cosmic compromise that somehow produces clarity. There's poetry hidden in that balance point. Too close to Earth, and you burn. Too far, and you freeze. But right here, between the two, you can see eternity. You can't help but wonder, if L2 is such a perfect balance between forces, could there be others out there, Lagrange points between galaxies? Or even between universes? Scientists haven't found them yet, but they argue about it, quietly, in conference halls and late-night forums. Maybe one day, another telescope will sail to a new balance point, far beyond even JWST's reach. But for now, you're here, hovering beside a golden flower drifting through the dark. It's weightless, precise, serene, forever watching, forever waiting. The telescope's orbit is small, but its gaze is infinite, and somewhere below, Earth turns in silence, unaware that one of its children now floats perfectly balanced between gravity and forever. You drift beside the telescope, your invisible feet brushing against starlight. The golden mirror tilts slightly, its hexagonal facets gleaming like a sunflower following the ghost of the Sunday. The silver sail below hums with unseen energy. And then, slowly, almost reverently, the telescope begins to look beyond what human eyes can see. Welcome to the realm of the invisible, the world of infrared light, where JWST reigns supreme. You've lived your whole life in visible light, that tiny sliver of the electromagnetic spectrum your eyes can handle, red to violet, about 400 to 700 nanometers wide, a laughably small range in cosmic terms. But beyond red, past the warmth of a campfire and the glow of a sunset, lies the infrared spectrum, a place of heat, dust, and ghostly radiance. That's where JWST's eyes open. It doesn't just see light, it feels it. The telescope is tuned to wavelengths between 0.6 and 28 microns. That's light so long, so slow, it's more like warmth than color. Infrared reveals things that visible light hides. Newborn stars cocooned in gas, galaxies veiled in dust, and the faint fingerprints of planets orbiting alien suns. The mainstream fact comes easy. JWST can see objects up to 100 times fainter than Hubble can in visible light. Not because it's larger, though it is, but because it operates where light has stretched too long to shine. The universe expands, and as it does, it stretches ancient light into redder wavelengths. JWST's infrared vision is, quite literally, tuned to time itself. You float closer to the mirror, trying to imagine what it sees. A region of space that looks black to you bursts into warmth and color through JWST's eyes nebulae, glowing galaxies shimmering, starlight bleeding through clouds that would look opaque in ordinary light. If Hubble is an artist, painting in bold strokes of color, then JWST is a sculptor. It shapes the unseen, carves the void, and shows us depth where there once was nothing. The telescope's instruments work together like a choir. NIRCam handles the shorter infrared wavelengths, capturing crisp images of stars and galaxies. NIRSpec breaks the light apart, turning it into spectra that reveal chemical compositions and velocities. MIRI, the coldest of them all, dives deep into the long wavelengths, mapping cosmic dust and heat signatures. And NIRIS, the Canadian-built eye, studies exoplanets, measuring faint dips in starlight that tell of distant atmospheres. You imagine them as musicians, each playing a different octave of light. Together, they compose the symphony of the unseen. Here's a quirky tidbit. JWST's instruments are so sensitive that if you stood a few kilometers away and held up a lit match, it could detect the heat from it. In fact, if you stood on the moon with a flashlight and aimed it right, JWST could spot the beam. Of course, you'd freeze or suffocate long before making that happen. But still, the thought warms you. Literally, you hover near one of the mirror's golden hexagons. Each one is reflecting photons that left their sources billions of years ago. You realize, suddenly, that you're surrounded by ghosts, not the spooky kind cosmic ones. Light that began its journey before the sun was born, traveling through expanding space until it found this telescope, this one golden trapdoor in the dark. JWST doesn't just observe, it resurrects. And yet, even now, scientists still argue whether seeing the universe in infrared gives us a truer picture than visible light. Some claim it's like peeling away the skin of the cosmos to reveal its bones. Others say it's like viewing a dream through smoke. The debate is oddly poetic, and maybe that's the point. Truth and beauty are never far apart. You glance toward a patch of sky that, to the naked eye, is utterly empty. JWST has pointed its mirror there too, a region no bigger than a grain of sand held at arm's length. And what it found was staggering. Thousands of galaxies, layered like fossilized time, each one a city of stars, some shining when the universe was less than 500 million years old. You let that number sit in your mind for a moment. Light that's been traveling for 13 billion years, finally reaching a mirror made by creatures who didn't exist when it began its journey. The telescope hums softly, its instruments whispering data down invisible beams toward Earth. In labs and offices across the world, scientists stay up all night, turning that data into color, false color, technically, but truthful in essence. Reds become golds, blues become violets, and every shade carries meaning. The signature of hydrogen, the glow of carbon, the warmth of dust. The universe isn't empty, it's just shy. JWST's infrared gaze coaxes it out of hiding. You can almost feel the heat patterns it sees, stars forming in clouds of molecular hydrogen, planets still molten from birth, the warm breaths of distant atmospheres. Every temperature difference becomes a language, and JWST is fluent. There's something intimate about infrared. It's the wavelength of warmth, of body heat, of living things. And here it's used to read the history of everything that ever lived, or might live. It's like the telescope is touching the universe's pulse through the fabric of time. You smile. drifting in the quiet glow. Somewhere inside JWST's cold core, electrons flow in patterns designed decades ago, collecting the light you could never see yourself. The telescope isn't alive, yet it feels aware, its golden gaze unblinking, its sensors always listening. One more fact slides into thought. JWST's detectors are so powerful that when engineers first tested them on Earth, they had to cool the room to near freezing and dim the lights to avoid overloading them. The telescope could literally see the warmth of a human hand behind a wall. And now, that same sensitivity is aimed outward, into forever. You picture JWST looking at a star-forming region, like the Carina Nebula, pillars of dust glowing red-hot in infrared, intricate and alive. The image ripples through your mind. Cosmic mountains sculpted by light, revealing detail finer than any dream. It's beautiful, overwhelming, quietly humbling. Infrared vision isn't about brightness, it's about patience. Light this ancient doesn't rush. It drifts, expands, fades. JWST waits for it, motionless and patient, collecting each photon like a drop of dew from the void. And maybe that's the secret you realize now. The telescope's power doesn't come from how far it can see, but from how gently it listens. You close your eyes metaphorically, of course, and for a moment, you almost feel the universe's warmth yourself. Soft, distant, infinite. You linger in the shadow of the golden flower, watching as it tilts and steadies. The mirror no longer looks random. It looks alive, as though it's breathing in starlight. But tonight, you're not here to admire its glow. Tonight, you're going deeper into the heart of how it became that flawless, shimmering machine. The story of its design and the ridiculous, borderline impossible precision that holds it together. Each hexagon of JWST's mirror, there are 18 of them, had to be machined with an accuracy so precise that if you scaled one up to the size of the United States, the tallest bump would be less than an inch high. The mirror's job is to catch faint light from the edge of the observable universe, and a single microscopic flaw could blur the image of an entire galaxy. It's all made of beryllium, a metal that sounds like something out of a fantasy novel, but behaves like a dream for engineers. It's strong, lightweight, and most importantly, doesn't warp when frozen to near absolute zero. Each segment weighs about 20 kilograms, yet it's coated with only a few grams of gold. Real gold? Yes, about $10,000 worth total, because gold reflects infrared light perfectly, bouncing it inward like warmth on a cold night. A mainstream fact: JWST's mirror is 6.5 meters across, making it more than twice the size of Hubble's. But size alone doesn't capture the magic. It's the segmented nature. The way those 18 petals fold out and align into a single optical surface that turns it from sculpture into miracle. You picture the unfolding process in the vacuum of space, a series of motors, hinges, and actuators slowly unfurling the mirror. It's ballet, mechanical and serene. And here's a thought to lose sleep over. Each segment is adjusted by 7 tiny motors, capable of nudging its position by just 10 nanometers. That's less than the width of a virus. If even one of those actuators jammed during deployment, the whole mission could have failed. The telescope would have become a $10 billion space ornament, beautiful, tragic, and blind. You imagine the engineers back on Earth, holding their breath during those nail-biting days in January 2022. Commands took seconds to reach L2, and the mirror responded like a slow-moving origami crane click. Pause, click, until finally, all petals were open. The cheers in mission control weren't just relief. They were disbelief that humanity had actually pulled this off. A quirky tidbit floats up. JWST's mirror was so sensitive during testing that engineers worried about their own heartbeat vibrations affecting alignment. They had to stand perfectly still or leave the cleanroom entirely when calibration lasers were active. Some joked that they were the only people in history asked to stop existing for science. You smile at that one. You'd probably be terrible at it. Imagine trying not to breathe while the future of astronomy depends on your silence. The mirror alignment phase that followed was pure artistry. Engineers fired a small laser at the mirror and watched the reflection bounce into the instruments. What they saw first was chaos 18 blurry stars scattered like confetti. Over weeks, they carefully adjusted each mirror, merging those separate images into a single perfect point. It was like teaching 18 stubborn students to sing in harmony, 1 nanometer at a time. Scientists still argue whether JWST's segmented mirror will ever surpass the optical perfection of a solid one like Hubble's. A single glass mirror is simpler, cleaner, but JWST's folding design allows it to fit inside a rocket, and once deployed, it becomes effectively seamless. The debate is almost philosophical perfection through unity or adaptability through fragmentation. You hover closer to one of the mirror's golden facets, tracing imaginary fingerprints across its smooth face. It's so still that your reflection doesn't shimmer. It waits. Each hexagon focuses on the same spot of sky, overlapping photons from billions of light-years away. The result is a unity of light, born from 18 separate eyes. But mirrors alone can't do everything. Behind them hides a network of wavefront sensors, tiny detectors that measure how light bends and distorts. These sensors feed information to computers that adjust each mirror in real time, a cosmic version of autofocus. It's mind-bending to realize that JWST's mirror alignment is so delicate it must compensate for differences smaller than a single atom. One wrong move, and a galaxy 13 billion light-years away could vanish into blur. And then there's the folding dance that made all this possible. To fit inside the Ariane 5 rocket fairing, JWST had to be folded like an interstellar origami puzzle. The mirrors tucked in, the sun shield wrapped tight, the tower collapsed inward. If you ever packed a tent, imagine doing that with 300 fragile mechanisms, knowing a single jammed pin could doom the mission. When the telescope finally reached its destination, 1.5 million kilometers from home, it stretched open like a flower blooming in eternal twilight. The mirror petals glinted in sunlight filtered through the thin gold layer, their shapes locked by actuators that would never move again unless commanded. You can almost hear it whispering through space. Finally. It's easy to forget how much of JWST's engineering came down to pure faith in math, in physics, in decades of testing on Earth. There's no fixing it once it's up there. No spacewalks, no rescue missions. It's too far. The telescope has to work perfectly for 20 years, operating colder than Pluto, with moving parts more precise than any clock. And yet here it is alive, seeing, thriving. You think about the beauty of that gold coating again. Gold isn't chosen for luxury, it's chosen for survival. Other metals tarnish, corrode, or absorb too much heat. Gold stays pure, reflecting the faintest whispers of light without judgment. There's poetry in that. The universe's most precious element used not for crowns or coins, but to look back in time. The mirror's reflection isn't really gold, of course. To JWST, it's black. It's tuned to infrared. Gold is invisible at those wavelengths. The color is, for us, a little artistic flourish so humans can see what the telescope cannot. Somewhere in the distance, a photon that left a dying star billions of years ago bounces off that mirror, hits a detector, and becomes a pixel on your screen. That's what this machine does. It turns eternity into information. You glance once more at the glimmering pattern of hexagons, realizing how fragile and brave it all is. 18 mirrors, 7 actuators each, all whispering in harmony across 1.5 million kilometers. You can almost hear their hum now, the faint vibration of perfect alignment, the sound of a billion years of light finding its way home. You float closer to JWST now, drawn not to its mirror or golden gleam, but to something subtler, the vast, silvery expanse below it. Stretched out like a cosmic parachute, it ripples faintly in the solar wind, layer upon layer of whisper-thin membranes glinting like frost. This, you realize, is where the magic of coolness begins. Meet the sunshield JWST's shimmering armor, its parasol against the fury of the Sunday. It's not just a sunscreen. It's the reason the telescope can even see in infrared at all. Without this extraordinary barrier, JWST would be blinded by its own warmth. Each of its 5 layers is made of a material called kapton, thinner than a human hair, but tough enough to survive micrometeoroid hits and radiation for decades. It's coated with aluminum to reflect heat, and the outermost layer gets an extra dusting of doped silicon to withstand the ultraviolet blaze of sunlight. A mainstream fact to start with: the sunshield keeps JWST's instruments at a steady 233 C, colder than liquid nitrogen. That's the temperature of cosmic silence, the kind of cold where even atoms barely twitch. You watch as sunlight hits the first layer. It sizzles with invisible energy, heating to about 125 C, roughly the warmth of a pizza oven. But each subsequent layer cools dramatically. By the time light filters through to the 5th, the temperature drops by over 300 degrees. It's like descending from a desert to deep Antarctica in a space thinner than your fingernail. That's the secret. Each layer radiates heat sideways, never downward. No conduction, no convection, only the pure ballet of radiation, bouncing away forever. If JWST were a person, this would be its skin-thin, vulnerable, yet perfectly tuned for survival. And yet, this skin almost killed it before it ever reached space. The sunshield had to unfold from 107 release mechanisms, 140 tensioning cables, and 8 motorized reels. Each one had to trigger in exact order, over several terrifying days, with no chance of a do-over. During testing on Earth, one of those thin sheets tore. A single snag, smaller than a credit card, shut the whole process down for months. Engineers described it as trying to unfold a bedsheet the size of a tennis court, while wearing oven mitts underwater in the dark. That image sticks with you. It's ridiculous. It's perfect. A quirky tidbit. When JWST's sunshield was first fully deployed in testing, it took up so much space they couldn't fit it inside NASA's cleanroom. The engineers had to borrow a hangar from the US Navy. Picture a bunch of scientists standing under something that looks like a futuristic kite, arguing about wrinkles with laser rulers. The moment of deployment in space was nerve-wracking. No cameras were placed to film it, too risky, too heavy. So mission control could only watch temperature readings and tension sensors, waiting for data that said, yes, the shield has opened. You can almost feel the silence that filled the control room when the fifth layer finally locked into position. A kind of awe mixed with relief. Humanity's most expensive blanket had unfolded flawlessly. You drift below it now, where the cold shadow lingers. Above the shield, sunlight blazes. Below it, perfect darkness reigns. The temperature difference between the two sides can exceed 300 C. A boundary so sharp, it's like standing at the edge of a thermal cliff. On one side, warmth and radiation. On the other, stillness and frost. JWST lives on the cold side, facing away from the sun, earth, and moon, all at once. It never looks back. Its instruments are buried in that eternal chill, peering into the warm past through a veil of ice. Scientists still argue whether 5 layers were truly necessary. Some claim 3 would have sufficed with better materials, while others insist even a 6th might extend JWST's life. But physics doesn't forgive wishful thinking, and 5 was the perfect balance between protection and weight. You glide closer, noticing tiny seams, micrometeorite scars already forming after years in orbit. Each one tells a story of impact, tiny grains of space dust hitting at 10 kilometers per second. None have pierced the layers, but you can see where the fabric flexed and absorbed the shock. JWST flinches quietly, endures, and keeps its cool. Literally, the sunshield doesn't just protect against heat, it shields against stray light. Any photon that sneaks through could ruin an exposure, just as a flashlight ruins a long photo of the night sky. JWST's instruments are so sensitive that a single warm pixel could masquerade as a star. The shield's purpose, then, isn't just temperature, it's purity. It keeps the telescope's eyes honest. There's something oddly human about it, you think. The way it hides behind a curtain to see the truth, refusing to stare directly into the light. It's like the telescope understands that revelation comes only from the shadows. The gold mirrors above gleam faintly in reflection, untouched by sunlight. The sunshield below ripples, vast and silent. Between them, JWST drifts like a monk, between 2 worlds, heat and cold, life and emptiness, birth and oblivion. You imagine what it feels like to exist there, to have one side perpetually burning and the other perpetually frozen. It's balance through contradiction, a yin and yang of cosmic engineering. Even now, down on Earth, teams monitor those layers, tracking tension and temperature in real time. Any change could spell disaster. A micrometeorite tear, a mechanical glitch, a thermal drift, and the telescope could lose its fragile equilibrium. But so far, it hasn't. The shield holds, the shadow remains, and maybe that's what makes JWST's design so poetic. It survives by not looking, by turning its back to the sun so that humanity can finally face the stars. You tilt your head and catch one final shimmer along the sunward side, where the doped silicon reflects a ghostly lavender hue. It's beautiful, in a utilitarian way, like the glint of a sword made only to defend silence. You can almost hear it sigh, the faint sound of heat leaving forever, radiating into the void. In that hush, JWST dreams not of warmth, but of the cold stories light brings from the beginning of time. You drift higher again, rising from the silvery sails of the sun shield back toward the golden petals above. The airwell, the emptiness, feels thinner somehow. JWST is silent, but the silence hums with purpose. Tonight, the telescope's gaze has shifted its mirror points toward a patch of sky, smaller than a sand grain held at arm's length. To human eyes, there's nothing there, just black, a void, and yet, JWST knows better. The mirrors steady, the detectors awaken. The observatory begins to drink in light that has traveled for more than 13 billion years. This is the moment when it sees the first galaxies, the faint smudges of cosmic dawn. You've heard of them. Maybe the JWST deep field images, those chaotic, dazzling mosaics of distant galaxies that look like someone spilled stardust on velvet. They're not just pretty pictures, they're fossils. Each one is a time capsule from when the universe was still a newborn. A mainstream fact: the light JWST captures from those galaxies began its journey roughly 300 million years after the Big Bang. That's practically infancy, cosmically speaking. The first stars had just begun to ignite, and space itself was still opaque with leftover hydrogen fog. You imagine the scene. JWST reveals tiny red galaxies, warped by cosmic expansion, smeared and stretched by gravitational lensing. Their light curves around invisible matter, magnified by galaxy clusters, acting as natural telescopes. It's space using itself to look at itself. Somewhere in that ancient glow, you can almost see the first sparks of starlight forming inside primordial gas clouds. The first elements, heavier than hydrogen, carbon, oxygen, iron, are being forged in those tiny furnaces. You can almost hear the universe clearing its throat, preparing to sing. The pictures JWST sends back are almost absurd in their detail. You can see spiral arms in galaxies so far away that their light left before the Milky Way even existed. Each dot isn't just a star, it's a city of stars, billions strong. And here's a quirky tidbit. When scientists first looked at the deep field data, they found too many galaxies. Dozens of bright, well-formed galaxies that shouldn't exist that early in the universe. The models predicted a messy infant cosmos, but JWST showed something strangely mature. It sent astronomers spiraling. Were the galaxies really that old, or were they imposters closer, dustier galaxies tricking the instruments? Scientists still argue whether JWST's early data has rewritten our understanding of galaxy formation or simply exposed the limits of our models. It's like discovering a toddler who already knows calculus. Either you misread their age, or the universe grew up fast. You glance at the field of stars, each one warped by invisible lenses of dark matter. Some of them shimmer oddly, distorted into arcs and streaks. JWST doesn't just see light. It sees the fabric of space-time bending under gravity's weight. You remember Einstein's words about how gravity isn't a force but a curve in space itself. JWST proves it. in every image, in every warped photon that reaches its mirror. And then, deeper still beyond the galaxies, you see something stranger, the faint red haze of hydrogen glowing from the epoch of reionization. That was when the first stars burned bright enough to clear the cosmic fog, turning the universe from opaque to transparent. It's like dawn breaking after an eternal night. JWST can detect that transition directly, reading the fingerprints of ancient hydrogen through the light it absorbs. Each dip in its spectra is a whisper from 13 billion years ago, saying, "Here, this is where light first won." You can't help but marvel at how it all began, from a tiny soup of quarks to this luminous web of galaxies. JWST isn't just taking pictures, it's unspooling time itself, turning darkness into narrative. You float beside the telescope as it tracks across the void, instruments open, absorbing photons one by one. It doesn't blink. It can't. It stares for hours, days, sometimes weeks, collecting every particle of light that dares to arrive. Here's another strange fact. In its first deep field, JWST collected millions of seconds of exposure time. Every second, a handful of photons hit the detectors, each carrying ancient information. The final image you see on Earth is built from those ghostly arrivals, mere trickles of light from the dawn of everything. Somewhere down on Earth, in control rooms, lit by monitors and coffee cups, astronomers lean closer to their screens. One whispers, "That smudge there, it's older than our galaxy." Another adjusts color balances, turning infrared data into visible images humans can comprehend. Reds become gold, blues become the color of youth. It's almost cruel. You think that JWST's vision is so perfect, yet we can never see the raw truth of it. Everything you see from it is translated, remapped, colorized for your limited eyes. You're peeking through the keyhole of infinity, seeing just enough to know what you're missing. Scientists still debate what these first galaxies mean. Some suggest they formed much faster than expected, fueled by dark matter halos collapsing early. Others think our understanding of light itself might need rethinking, that cosmic expansion or dust absorption might be tricking us. The data is fresh, fragile, controversial, and that's what makes it beautiful. You imagine JWST as a time traveler, hovering just beyond the veil of the Big Bang, watching the first stars blink into existence. If you could stand beside it and look the same way, you wouldn't see fireworks or explosions, just faint, rosy glimmers emerging from the black. The birth of light itself, and all of it, every shimmer, every curve of galaxy, every ancient photon is falling now, softly, into a golden mirror floating in silence. You wonder if the telescope ever feels lonely out here, suspended between what was and what is. Probably not. It's too busy listening. The first galaxies form. Their light crosses eternity, the mirrors gleam, and you, somehow, get to see it all. Maybe that's the strangest, most humbling part. That the universe took 13 billion years to make a scene this beautiful, and then waited for you to fall asleep beneath it. The golden petals tilt again, slowly, almost reverently, and JWST's gaze shifts towards something smaller, more intimate, a single point of light lost among galaxies. The first time you see it, you think it's just another distant star. But then the data starts to sing, and you realize that tiny glimmer isn't a star at all. It's a planet, You're entering one of JWST's most haunting realms, the study of exoplanets, those distant worlds orbiting suns light years away. Once upon a time, the idea of other planets was pure speculation. Then the Kepler Space Telescope revealed thousands, but Kepler could only tell you that they exist. JWST goes further. It tells you what they're made of. You float closer to the telescope, watching as its mirror aligns toward a familiar name, WASP 39b, the target of one of JWST's first great triumphs. It's a gas giant about 700 light-years away, bloated, puffy, and glowing from its star's heat. When JWST looked at it, the light from that star passed through the planet's atmosphere before reaching the telescope's detectors, and in that faint, filtered glow, JWST read something no human instrument had ever seen so clearly before: the chemical fingerprint of an alien sky. A mainstream fact to anchor this moment. JWST detected carbon dioxide in an exoplanet's atmosphere for the first time in history. It also spotted water vapor, sodium, potassium, and even sulfur dioxide, proof that photochemistry is happening out there, far from home. That's not life, but it's a chemical conversation. You watch as light bends through the thin veil of that distant planet's air. JWST's spectrographs break it apart, pixel by pixel, into lines and dips. Every dip means an element, every curve a molecule. It's like reading the ingredients list of a world that no one will ever touch. A quirky tidbit: one astronomer joked that JWST is the universe's first sommelier, tasting the atmospheres of distant planets through light alone. It's absurd and perfect. You can almost picture the telescope swirling a beam of starlight and murmuring, notes of water vapor, a hint of sulfur, slightly overcooked hydrogen. Scientists still argue whether these early detections mean we're close to finding a habitable planet, or just teasing ourselves with tantalizing chemistry. Some say JWST will eventually find biosignatures, methane, oxygen, or ozone that could hint at life. Others warn that nature loves to fake those signals. Methane can come from volcanoes, oxygen from photolysis. It's like trying to tell if a house is lived in by smelling smoke from 10 galaxies away. Still, JWST is designed for that chase. Its NIRSpec and NIRIS instruments can observe a planet as it crosses in front of its star, measuring the tiniest dimming in starlight, sometimes just a fraction of a percent. From that, it extracts atmospheres, temperatures, and even weather patterns. Imagine that. A telescope, 1.5 million kilometers away, reading the weather forecast on a planet light years distant. You drift alongside it as it peers at another target, TRAPPIST-1, the famous system with 7 Earth-sized planets orbiting a cool red dwarf. JWST's detectors hum faintly as they collect starlight that's been strained through those atmospheres. Each line in the spectrum might mean water, or clouds, or carbon, maybe life, maybe not. But still, the thought that those planets exist at all, and that one of them might have oceans glinting under alien sunlight, it's enough to make your heart stutter. JWST doesn't just stare. It listens for subtle rhythm. A slight wobble in the star's light curve can reveal moons, or clouds, or even auroras. The telescope's precision is so fine that it could detect the signature of a single part per million of certain gases. Down on Earth, data analysts drink too much coffee and argue over blips. Is that methane or noise? Is that oxygen or calibration error? They're chasing ghosts through light, and every discovery feels like decoding a cosmic love letter that might or might not be addressed to us. You think about how strange it is that we can know so much about places we'll never visit. JWST can't image these planets directly. Not most of them. It only reads echoes, light that's been filtered, dimmed, and delayed. It's like learning the taste of a fruit from the scent on someone's breath. But even that whisper is enough to change everything. Scientists still argue, heatedly but lovingly, over what counts as proof of life. Is it oxygen in tandem with methane, a repeating chemical imbalance, or will it be something we can't even name, yet some new form of chemistry that mocks our definitions? JWST doesn't argue. It just keeps staring, cold and patient, collecting photons that know the answers. And then there are the eerie surprises, like the detection of SO2 sulfur dioxide in WSP-39b's skies. That means the planet's atmosphere is alive with photochemical reactions, ultraviolet light sculpting molecules in real time. You imagine it, a vast, cloud-swirled gas giant where sunlight creates and destroys chemicals in endless cycles. Not life, but motion. A breathing atmosphere in a lifeless world. There's beauty in that too. The telescope shifts again, locking on another candidate, K218b, a super-Earth orbiting in its star's habitable zone. Early JWST data hinted at water vapor there, maybe even dimethyl sulfide, a molecule associated with life on Earth. The internet erupted in excitement. Did JWST just sniff an alien ocean? Or was it just a data artifact? A cosmic mirage born of noise and hope? The debate continues. Somewhere between those wavelengths, truth hides. JWST keeps watching. It doesn't tire. It doesn't dream. You look at the golden mirror again, realizing it's not just reflecting light, it's reflecting longing. Every beam it catches carries humanity's quiet question. Are we alone? The telescope doesn't answer. It only gives you evidence and the silence between the numbers. Still, you can't help but imagine that maybe, just maybe, one of those dimming stars has a small blue world orbiting its oceans, clouds, someone out there looking back at their own faint sun and wondering the same thing. JWST wouldn't smile at that thought, but you do. Because even if it never finds life, the act of looking, that endless, tender curiosity, is its own kind of miracle. You drift with the telescope as it turns again, pivoting away from the known towards something even older. The primary mirror catches faint whispers from the edge of time itself. This is JWST's most profound mission, to look so far back that it sees the dawn of everything. You remember how light works. The farther it travels, the older it is. Look at the moon, and you see it as it was a second ago. Look at the sun, 8 minutes ago. Look deep enough into space, and you're staring into the past. JWST is a time machine made of gold and silence. Its instruments, NIRCam, MIRI, NIRS, SPEC, don't just take pictures. They stretch time into something visible. By catching infrared light that's been traveling for over 13 billion years, The telescope peers into a universe that was still learning how to glow. You watch as it targets GNZ 11, one of the most distant galaxies ever recorded. To the human eye, it's nothing more than a dim smudge, but JWST's sensors drink in that faint radiation, pixel by pixel, revealing a galaxy that existed when the universe was barely 400 million years old. A cosmic toddler, just starting to form stars. It's strange to think of light this old. Each photon that hits JWST's detectors began its journey when matter itself was new, when no stars had yet died, when no planets had yet formed. Some of those photons left their galaxies before Earth existed, before atoms in your body even coalesced inside ancient stars. You imagine those photons traveling for billions of years, dodging interstellar dust, slipping between galaxies, bending through gravity wells only to finally land here, on this floating gold mirror, built by beings who evolved on a small blue planet. You think, they've been traveling longer than we've been alive as a species. That's the scale JWST plays in light. Older than memory, older than language. Its discoveries have already rewritten textbooks. The telescope's very first deep field, the now iconic SMACS 0723 image, showed thousands of galaxies in a single frame, each a collection of billions of suns. But what stunned astronomers wasn't just the beauty, it was the density. There were too many galaxies, too early. According to standard cosmology, galaxies that massive shouldn't have formed that fast after the Big Bang. Yet JWST found them. Some are so mature, so structured, that they seem to defy models of how matter assembled in the early universe. It's as if JWST turned its gaze into the past and found the universe already awake before it should have been. Astronomers jokingly call it the cosmic dawn crisis. Some say the early galaxies might be misidentified. Maybe they're smaller or redder than expected. Others whisper that perhaps our understanding of the early universe is flawed. Maybe dark matter behaved differently than we think. Maybe star formation was more efficient. Maybe physics itself needs adjusting. Whatever the answer, JWST forced humanity to admit a humbling truth. Even after centuries of looking, we're still beginners. You float above its golden mirror and feel the scale of what it's doing. JWST is reading the first chapters of cosmic history, line by line. It sees the light of population 3 stars, the first ones ever born, made purely of hydrogen and helium, without the heavier elements forged by later generations. Those stars burned blue and massive and died young, scattering the seeds of all future worlds. When JWST finds traces of their explosions supernovae, lighting up the darkness, you feel something ache deep inside. Because in those deaths, everything began. Carbon for your cells, oxygen for your lungs, iron for your blood. The telescope isn't just watching the past, it's watching your own origin story unfold in reverse. A quiet fact to ground the wonder. JWST can see wavelengths from about 0.6 to 28 microns deep into the infrared, invisible to human eyes, but perfect for seeing through dust and cosmic fog. That's why it can uncover stars still forming in their dusty nurseries, or galaxies hidden behind veils of interstellar smoke. Its mirrors, cooled to near absolute zero, must remain colder than -223 C. so the telescope's own heat doesn't blur the ancient light it's trying to see. That's what the sunshield does. 5 vast layers of silvered Kapton film, each thinner than a human hair, reflecting sunlight away like a cosmic parasol. Without it, JWST would be blind. You glance at that shimmering shield, stretched taut beneath the telescope like a silken sail. It's not just protecting an instrument, it's preserving the universe's oldest light from being drowned in warmth. And the result? JWST has already spotted galaxies with redshifts beyond Z=13, meaning their light left them over 13.4 billion years ago. It's seeing cosmic structures from when the universe was less than 3% of its current age. You feel dizzy at that number. Somewhere among those galaxies, tiny, red, and far was the moment everything familiar began to take shape. Dust turned to stars, stars to planets, planets to oceans, oceans to life, life to minds that could build telescopes to look back and see it all. The telescope doesn't weep at that irony. But maybe you do, because JWST isn't just showing us the past. It's showing us how miraculous it is that we exist at all. One astronomer said, half serious, that every deep field JWST captures is a form of therapy. It's hard to worry about emails, she said, when you're staring at light from 13 billion years ago. You smile at that. She's right. The scale of it calms you. The sheer, impossible age of everything makes your own worries seem like ripples on the surface of an eternal sea. You float there a little longer, listening to the silence of a telescope that has seen the first dawn of the cosmos and still keeps watching for more. Each photon that hits it is a messenger from the beginning, whispering, "We were here. We began this. And now, so do you." You drift deeper into the vision, where galaxies are no longer distant pinpoints, but living, colliding giant slow-motion disasters that take millions of years to unfold. The Webb telescope hangs in the cold, its mirror angled toward the cosmic ballet of collisions, watching entire galaxies embrace and tear each other apart. It's beautiful in a terrifying kind of way. You watch 2 spirals, one blue and young, the other reddish and old, spiral inward like lovers dancing to a music so low you can only feel it in your bones. Their stars don't technically crash. Space is too vast, but gravity does something wilder. It stretches, pulls, and merges billions of suns into new configurations. Dust clouds ignite into fresh starbirths, cores collide, and supermassive black holes at their centers start orbiting each other, their immense masses warping space like ripples in glass. JWST catches it all, not in real time, but frozen frames of time so long ago that what it sees happened before Earth had life. Its infrared gaze slices through clouds of glowing dust, revealing star nurseries that look like rivers of molten copper. The telescope doesn't just see the violence, it sees the creation inside destruction. Every collision seeds new galaxies, new stars, maybe even new life. You think of it as a kind of cosmic composting. Nothing wasted, everything recycled into another round of creation. In JWST's data archive, there's one collision astronomers can't stop showing off: the antennae galaxies. Their tendrils stretch across space like the arms of dancers caught mid-spin, each packed with star clusters blazing hot in the infrared. Some are no bigger than a few light years across, yet they contain tens of thousands of stars being born at once. And the best part? JWST's infrared vision captures these scenes through the dust, where older telescopes only saw opaque shadows. What once looked like a faint smear now glows with layered structure, color, and motion. If you were close enough to see it with your own eyes, you wouldn't. You'd be vaporized instantly, of course. But let's ignore that small detail. Instead, you float safely with the telescope, watching the light of chaos bloom in slow, silent spirals. Mainstream science says galaxy mergers are essential to the growth of large galaxies like our own. The Milky Way, in fact, owes its size to countless smaller collisions over billions of years. And in another 4 billion, it will meet its partner, the Andromeda Galaxy, in a graceful, catastrophic waltz. That's right. Someday, your home galaxy will merge, too. You'll be long gone. But JWST might still be remembered as the instrument that showed us how it happens elsewhere. How beauty and violence can coexist in one gravitational embrace. Scientists still argue whether these collisions trigger or suppress star formation. Some models show bursts of creation, others a temporary quenching. The universe doesn't bother clarifying. It just keeps doing both. In one of JWST's deep field images, astronomers found evidence of a triple merger. 3 galaxies crashing together, their shapes twisted into a fractal of glowing gas and filaments. You trace the image with your eyes. It's not chaos, it's choreography. Every arm, every swirl, every stream of stars is a record of gravitational music playing across billions of years. JWST's instruments don't just photograph the scene, they read it like a forensic file. By measuring redshift, the telescope determines each galaxy's motion and distance. By analyzing spectra, it detects which elements burn in the chaos: hydrogen, helium, oxygen, neon. Even the faint glow of polycyclic aromatic hydrocarbons, complex molecules that might one day build life appear in its view. That's the quiet miracle of these collisions. From chaos, chemistry. From heat, habitability. From destruction, the raw ingredients of someone else's home. You watch as one galaxy's spiral arm breaks, flings a stream of stars into the void. In that trail, new worlds are born tiny, spinning, orbiting suns that will never know they were once part of a larger whole. Cosmic orphans, but brilliant nonetheless. There's a philosophical echo there. You can't help but notice it. Everything collides, everything reshapes, and still, the universe finds a way to build something new. Galaxies do it. People do it. Maybe that's the point. JWST is like an ancient historian with an eye for drama. It doesn't just observe, it interprets. Its images of colliding galaxies aren't static. They're frames in a movie we can't fully see yet. Every image you've ever scrolled past on a science feed, those glowing spirals, those fiery clouds, those are moments that took millions of years to happen. And JWST caught them as they were, frozen in light, older than anything you've ever known. It's humbling, isn't it? That our entire species, with all its noise and invention, built something that can quietly watch the sky remember itself. You drift closer to the mirror's reflection. For a second, you imagine JWST isn't just seeing galaxies, it's seeing thoughts. Curiosity reflected as data, wonder stored as light curves, the human instinct to understand turned into a golden machine orbiting in silence. And maybe that's why its images feel so spiritual. You're not just looking at physics, you're looking at memory. The universe remembering what it once was. A small, quirky note for your sleepy mind. In 2023, JWST's sensors accidentally picked up diffraction spikes that resembled Christmas stars in some images, creating viral memes of space tinsel. NASA scientists laughed. Even perfection comes with a bit of personality. Somewhere between laughter and awe, you feel your breathing slow. The collisions continue silently, as they always have. Stars ignite, dust blooms, galaxies merge, and somewhere between them, a human dream of understanding floats quietly, collecting their light. You can almost hear it hum a lullaby written in wavelengths, ancient and infinite. The telescope drifts again, this time turning its golden eyes toward the dark hearts of galaxies, where light itself is pulled into hunger. You follow, breath slow, as JWST peers into the invisible maelstroms that anchor galaxies. Black holes, the ultimate contradictions of physics. From this vantage, the centers of galaxies don't look like peaceful spirals of light. They look like whirlpools in a cosmic sea. Every strand of gas, every wandering star, bends toward the middle. You imagine gravity as a sound here, a deep, endless hum. JWST can't hear it, but you can almost feel it in your chest. At the heart of nearly every large galaxy, there's a supermassive black hole, millions or billions of times heavier than the Sunday. Ours, in the Milky Way, is called Sagittarius A*, a lazy eater compared to others, quietly sipping gas and dust rather than tearing it apart in tantrums. But JWST's gaze isn't limited to home. It peers into galaxies where black holes are feasting, glowing with radiation that no human eye can see. The irony is perfect. Black holes themselves emit no light, yet the matter falling into them blazes brighter than anything else in the universe. JWST captures these accretion disks in infrared detail, rings of fire swirling around absence. You stare at one such image and feel the paradox settle in. It's a photograph of nothing, lit by everything trying not to fall in. Astronomers call some of these cosmic monsters quasars, galaxies whose centers are so active, their black holes outshine all their stars combined. One quasar, JWST, studied lies over 13 billion light-years away, meaning the telescope is seeing it as it was when the universe was only 700 million years old. Its black hole already weighed hundreds of millions of suns. That's one of JWST's biggest puzzles. How did something that massive form so quickly? Scientists still argue whether black holes in the early universe were born from collapsing giant stars or from vast clouds of gas collapsing directly under their own gravity. Some even propose seed black holes that grew at impossible speeds, feeding faster than current physics allows. You can almost picture it, the universe barely out of infancy, already dotted with monsters, and yet there's beauty here. The gas and dust spiraling toward those black holes glow in every wavelength JWST can see. The telescope's NIRS spec instrument can split that glow into spectra, revealing chemical fingerprints hidden inside the chaos. Hydrogen, iron, even carbon compounds that may later form planets and life. That's the strange gift of destruction. Creation's raw materials. Every atom that falls into a black hole first dances in incandescent color, painting the edges of the void. You linger on one observation: JWST's infrared eyes capturing a galactic core surrounded by a vast, dusty ring. At its center lies a dark mass millions of times the sun's weight, invisible but undeniable. Around it, stars orbit at incomprehensible speeds, a celestial carousel whirling in silence. A mainstream fact to anchor the wonder: JWST can detect infrared light with wavelengths up to 28 microns, allowing it to cut through dust that blocks visible light. That's why it can see these galactic hearts so clearly when older telescopes could only guess. In one galaxy, Sears 1019, one of JWST's earliest find scientists discovered a black hole that shouldn't exist yet, at least according to previous models. It's relatively small by cosmic standards, about 9 million solar masses, but it lived at a time when the universe was too young for black holes like it to have grown. The discovery didn't just surprise astronomers, it delighted them. Because every impossible object JWST finds pushes our understanding further. You can almost hear the debates echoing across the halls of research institutes. Maybe early galaxies formed faster than we thought, or maybe the laws of gravity changed under those conditions. Or maybe, someone whispers, half joking, the universe just likes to keep secrets. A quirky tidbit to keep you awake a little longer. JWST's instruments are so sensitive, they have to watch out for rogue cosmic rays that mimic the signals of distant black holes. Sometimes a stray proton from the sun zaps the detector, leaving a false star. Astronomers lovingly call these glitches space zits. Even billion-dollar telescopes get bad skin days. Still, when JWST's images are real, they're unforgettable. In one shot, a spiral galaxy's heart glows like an ember, surrounded by arcs of dust that look sculpted by invisible fingers. Those arcs are shock waves, evidence of energy jets fired from the black hole's poles, slicing through light years of gas. You'd think something so violent would end everything nearby, but it doesn't. It shapes it. Those jets compress gas clouds, triggering new star formation farther out. Even black holes, the destroyers, end up creating. You find that strangely comforting, that even in cosmic violence, something tender can emerge. JWST's role isn't just to observe. It's to remind us that light always finds a way to exist around darkness. The telescope's sensors translate invisible infrared radiation into color images we can see. Fiery reds, cool blues, dusky golds. Every pixel is a photon that once brushed the event horizon of oblivion, then escaped to tell its story. You imagine that photon's journey, born in a spiral of gas, flung outward by a magnetic field, drifting through billions of years until it reaches JWST's mirror, a final act of survival. You're watching ancient courage, coded in light. For a moment, you forget you're floating above an instrument. It feels alive, doesn't it? A silent witness to everything the universe has tried to hide. Somewhere far below, humans argue over budgets and deadlines. Up here, JWST just listens. It doesn't care if a black hole is ancient or impossible. It just keeps collecting the truth, one photon at a time. The telescope adjusts, its mirror tilting slightly, as if nodding at your thoughts, and then it moves on, leaving behind galaxies that spin in eternal hunger, burning their brightness around the darkest centers imaginable. And somehow, in that quiet observation, you feel calmer. Because if light can survive even that, maybe so can you. You drift with JWST as it glides to its next cosmic tableau. The graveyards of stars, the luminous remains of things that once burned bright. It's an odd comfort, realizing even stars die, but their deaths aren't endings. They're art. And JWST, ever the silent artist, paints their ghosts in wavelengths unseen by any human eye. You're looking now at the Carina Nebula, one of JWST's most breathtaking portraits. It's a colossal nursery of gas and dust, and among its clouds, stars are both being born and dying. The telescope's infrared vision peels back the veil, revealing towers of vapor that stretch for light years, pillars of gold and copper and shadow. If you could breathe in that place, you can't, but dream with me. The air would shimmer with the light of endings and beginnings, all at once. In one corner of that nebula lies a dying star wrapped in a cocoon of glowing gas. To the naked eye, you'd see only a faint smudge, but JWST's sensors finely tuned and infinitely patient capture filaments of gas curling like smoke rings, evidence of the star's final breaths. Each ripple marks a pulse, a last heartbeat before silence. That's what astronomers call a planetary nebula, a misnomer, because it has nothing to do with planets. It's a star's death mask, glowing as its outer layers are thrown into space. JWST's instruments reveal the chemistry inside: carbon, oxygen, nitrogen, the elements that will one day form rocks, rivers, cells, and maybe someone who whispers back to the stars. You notice how eerily peaceful it looks. Death, in space, isn't violent. It's theatrical. The telescope turns toward another scene. The Southern Ring Nebula, one of JWST's first famous captures. Two stars orbit at its heart, one alive, one dead. The living one's light illuminates the ghost of its twin, making it appear like an eye in the void, iris wide open. It's strangely human, almost sentimental, as if the surviving star can't quite let go. JWST doesn't see sentiment, but you do. The dying star's expelled gases, those gossamer rings, expand outward over thousands of years, cooling and drifting until they mix into the interstellar medium. One day, they'll become part of another star, another planet, maybe another set of eyes staring back through another telescope. Nothing wasted, nothing truly gone. Mainstream science fact: JWST's instruments, particularly NIRCam and MIRI, are designed to capture light from 0.6 to 28 microns. This allows astronomers to visualize the molecular composition of dying stars' debris, tracing how elements scatter and combine. That's how we know that stars like these seed the cosmos with life's essential ingredients. There's a poetic cruelty to it. Everything you are once belonged to something that exploded. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all of it forged in the cores of long-dead stars. When JWST peers at those glowing remnants, it's really looking at your ancestry. You smile at that thought. You're made of nebula dust, cooled and collected into something that dreams. A more mysterious case flickers across the screen: supernova remnants. Those violent deaths that make planetary nebulae look like candlelight. One of JWST's early deep-field targets was the Cassiopeia A region, a chaotic swirl of debris from a star that exploded 340 years ago in Earth's time. In JWST's infrared image, you can see ripples of iron glowing faintly red, calcium shining orange, and unidentifiable filaments twisting like threads in a tapestry too big to touch. Scientists still argue whether these explosions leave behind neutron stars, black holes, or something stranger, objects so dense and magnetic they defy our models. Some astronomers even suggest that certain supernovae might trigger the formation of magnetars, stars with magnetic fields 1 trillion times stronger than Earth's. You think about that, how something can die and yet leave behind a relic more extreme than what it was alive. There's a metaphor there somewhere, if you want to take it personally. JWST also peers into Wolf-Rayet stars, those bright, unstable giants shedding their layers in anticipation of a final collapse. In one image, WR124, the star gleams like a torch behind waves of expanding gas, each filament a fragment of its old self, cast into eternity. Astronomers call this a preview of a future supernova, but you can't help feeling it's more like a love letter written in hydrogen and dust. I was here. I burned beautifully. A quirky tidbit. When JWST's data first revealed WR124's intricate filaments, some viewers compared it online to celestial cotton candy. NASA's official response was, of course, more serious, but even scientists can't resist a bit of whimsy when confronted with such delicate chaos. And that's what makes this telescope special. It doesn't just collect data, it collects wonder. Every nebula, every dying star, is a reminder that the universe is an artist, and JWST is its most devoted gallery curator. You picture those gold mirrors catching the faint, faraway light of things that have already burned out. The photons travel for thousands, sometimes millions, of years just to arrive here, be detected, and turned into an image you can scroll past on your phone. It feels absurdly intimate, the last breath of a sun, turned into wallpaper for your screen. You close your eyes for a second and imagine what it would sound like if space could whisper perhaps a slow sigh of expanding gas, or the echo of a star saying goodbye. But there's no sound, only the hum of instruments, the patient heartbeat of a machine that never sleeps. And in that silence, you realize something simple and infinite. Everything that dies in the universe leaves behind beauty. JWST just makes it visible. You float there, half dreaming, watching the colors fade into black. The nebula dissolves, the dying star fades, but somewhere in that darkness, new stars are already forming from the same dust. Life, even here, is cyclical. You exhale and feel yourself drifting further into calm. You're still floating weightless, hushed while JWST repositions again, its mirror pivoting toward the deep cosmic scaffolding. What it's about to reveal isn't stars or galaxies this time, but the invisible hands shaping them all. Dark matter and gravity, the universe's hidden sculptors. To the naked eye, there's nothing here, just blackness. But JWST's sensors hum softly, collecting faint distortions in light that betray the presence of something enormous, something unseen. You've probably heard the phrase dark matter tossed around before. It sounds mysterious, and it is. Roughly 85% of all matter in the universe is this invisible stuff, yet no one's ever directly detected it. It doesn't glow, doesn't absorb, doesn't reflect light. It simply pulls. Its only fingerprint is gravity, and that's where JWST's genius comes in. By observing how light bends and warps as it passes through deep space, the telescope can map gravity's fingerprints, the subtle arcs and stretches caused by massive, invisible clumps of dark matter. These distortions are called gravitational lensing, and JWST sees them in exquisite detail. You gaze at one of its images, perhaps the SMACS 0723 cluster again. Now not just a gallery of galaxies, but a hall of mirrors. The bright elliptical cores at the center act like cosmic magnifying glasses, their mass bending space-time itself. Around them, distant galaxies appear stretched into elegant arcs, like reflections seen through rippling water. Those arcs aren't optical illusions. They're proof that space-time bends. Einstein predicted it, Hubble saw hints of it, but JWST reveals it with astonishing clarity. You imagine those galaxies behind the cluster. So far away, their light started its journey before Earth existed, made visible only because another galaxy's gravity curved their light toward us. A cosmic coincidence that feels almost intentional. Scientists still argue whether dark matter is made of unknown particles, WIMPs, axions, sterile neutrinos, or if we're misunderstanding gravity itself. Maybe the equations need rewriting. Maybe there's a whole hidden sector of physics that we just haven't met yet. JWST can't solve the mystery alone, but it's giving astronomers their sharpest tools yet. Every gravitational lens it captures helps map the cosmic web, that vast network of filaments connecting galaxies across billions of light years. You picture it now. Strands of invisible mass stretching like spider silk through eternity, glowing faintly with trapped galaxies. The telescope's images show that galaxies aren't randomly scattered. They gather along those filaments, leaving dark voids between them. Cosmic deserts where almost nothing exists. And yet, even those voids aren't truly empty. Quantum physics whispers that even nothing teems with potential. Particles flickering in and out of existence faster than thought. JWST's deep fields touch the edge of that mystery. You stare at one, the CER's deep field, for instance, and realize every speck is a galaxy, each one a cosmic address in this grand invisible web. The pattern is hypnotic. Galaxies line up like glitter in a magnetic field, tracing the pull of things you'll never see, a mainstream fact to anchor your awe. Gravitational lensing allows JWST to observe galaxies up to 100 times fainter than it could otherwise detect. It's like nature built a cosmic telescope for our telescope, the universe helping itself be understood. You think of the irony. Humanity built a machine to look outward, only to find reflections of something deeper and entire architecture hidden beneath everything visible. And then, a quirky fact. Gravitational lensing sometimes creates Einstein rings, perfect halos of light, where a background galaxy is stretched symmetrically around a foreground mass. Astronomers call them space donuts. You grin, because even in cosmic physics, someone had to make it sound snack-related. But behind the humor lies something profound. JWST has captured partial Einstein rings so clear You can almost trace their curvature with your finger. Those rings tell stories about mass and matter, about how invisible forces shape visible beauty. It's hard not to find that poetic. You're surrounded by proof that what we can't see defines what we can. If you could hover far above the cosmos, higher than any telescope, you'd see it all at once. An infinite lacework of glowing threads and dark gaps, clusters and filaments, forming a structure so vast it almost looks alive. Astronomers call it the cosmic web, but it's more than geometry. It's memory. The universe remembering the moment of its birth, still echoing the Big Bang's first patterns. JWST's deep infrared sensitivity lets us peer along those filaments, tracing how gas flows from emptiness into galaxies, feeding their stars, keeping them alive. You picture it like cosmic veins pulsing with hydrogen. Even in the void, there's circulation life at a scale you can't fully grasp. And within that web, dark matter is the framework. Without it, galaxies would fly apart. It's the skeleton of the universe, the scaffolding upon which all the glowing parts are hung. It's funny how much of existence relies on what's invisible. The universe, your body, your mind, they all depend on things unseen, unmeasured, but undeniably real. JWST keeps looking, patient and quiet. It can't see dark matter directly, but it can see its effects perfectly. Every stretched galaxy, every warped arc, every faint echo of gravity made visible by light's surrender. You let that thought linger. Everything is connected, even by forces you'll never feel. There's a tenderness to it. Once you stop fighting the incomprehension, maybe that's what JWST teaches best, that not understanding is part of the beauty. That mystery is not a failure, but a rhythm. You watch the invisible universe flicker through the telescope's data. Strings of equations turned into swirls of light. The darkness isn't empty. It's just waiting for the right eyes to notice. And for tonight, those eyes are yours. You drift deeper now, through the hush of cosmic space, where even time feels stretched thin. JWST turns its gaze towards something stranger than light or gravity. Time itself. The telescope isn't just a camera. It's a time machine, peering billions of years backward, watching galaxies being born while the universe was still finding its rhythm. The photons striking its detectors tonight may have left their galaxies over 13 billion years ago, long before Earth existed, before the Milky Way was even a whisper. You're literally bathing in ancient light. Light that traveled through expanding space, redshifted and thinned, its wavelength stretched like taffy, until only JWST's infrared eyes could catch it. There's something poetic about it. You're watching history play in reverse, galaxies aging backward into youth. JWST captures them as tiny crimson smudges, faint, barely there. Yet each one is a cosmic nursery, where the first stars kindled their glow in hydrogen clouds, untouched by anything before them. Scientists call these population 3 stars, the first generation ever formed. Made almost entirely of hydrogen and helium, they burned hot and lived fast, some lasting only a few million years. JWST hasn't seen one directly yet, but its instruments hint at their fingerprints in the light of the earliest galaxies. It's like smelling smoke and knowing a fire once blazed. You imagine one now, enormous, blue-white, searing with nuclear fury, collapsing under its own weight to forge the universe's first metals: carbon, oxygen, iron, the building blocks of life, all born from the corpses of stars that JWST can just barely glimpse. The telescope's near-spec instrument separates this ancient starlight into rainbows, spectra filled with clues. Each tiny dip and peak in the light tells a story of chemistry and temperature, of motion and distance. JWST isn't just seeing, it's decoding. Like reading Braille from the dawn of time, a mainstream fact slides in quietly. JWST's sensitivity is so great, it can detect a candle flame on the moon from Earth. In space terms, that means it can see a galaxy whose light has been traveling for over 13.4 billion years. That's not just impressive, it's almost unsettling. You think of the irony. Humans, fragile and fleeting, built a machine that can outstare eternity. There's a fringe theory that makes you pause. Some physicists think that by observing ancient light, JWST could stumble upon evidence of bubble universes, faint scars in the cosmic background, where other universes might have brushed against ours during inflation. No proof yet, but the thought tickles your imagination. You picture tiny universes bumping shoulders like soap bubbles, leaving ripples JWST might one day see. Scientists still argue whether what JWST glimpses at the edge of visibility are truly the first galaxies, or merely gravitationally magnified illusions, tricked into focus by massive intervening clusters. The data is clear, but the interpretation dances, reality bending under its own complexity. But the images keep coming. One galaxy, affectionately named Glass Z13, appears as it was when the universe was only 320 million years old, a toddler, cosmically speaking. You gaze at it, knowing the light left that galaxy before the Milky Way, before the sun, before life. It feels impossible that something so small in the sky could hold such weight in meaning. JWST's deep field surveys, like jades and seers, dive even deeper, revealing galaxies packed tighter than a beehive, flickering red with youth. Each one is a collection of suns, dust, and gravity caught in the act of becoming, and the telescope records them in silence, pixel by pixel, photon by photon, until the image blooms. The early universe wasn't peaceful. It was chaotic, filled with violent mergers, supernovae, and black holes devouring gas clouds. JWST watches that drama unfold, not as explosions, but as whispers of light, faint signatures that survived eons to tell their story. A quirky fact to lighten the awe. The software that cleans JWST's data sometimes hears phantom signals, heat ghosts from the telescope's own electronics, that scientists affectionately call space tinnitus. Even JWST, it seems, hums with the echoes of its own machinery. You imagine those hums mixing with the cosmic microwave background, the faint afterglow of the Big Bang, a soft static that's been playing since the beginning. JWST doesn't listen to that directly, but its vision fills in the gaps, linking the afterglow's faint warmth to the galaxies that grew from it. Somewhere in all that noise, there's order. You can almost feel it, the steady pulse of physics that carried light this far. And as JWST peers deeper, the question shifts. Are we looking at the past, or are we watching the universe recreate itself right now? Because every photon it catches still exists, still vibrates, still carries energy across space-time. The past, in a sense, is never really gone. It's just stretched thinner. You let that thought dissolve, the way light does when it travels too far. Everything you see is already over, yet somehow still present. The galaxies you admire tonight are ghosts, and yet their beauty feels alive. In that realization, something gentle unfurls. The universe isn't a story of loss, but of persistence. Light never stops trying to be seen. JWST hums on, patient as eternity, turning ancient photons into dreams. You breathe slower, matching its rhythm, floating through history, one wavelength at a time. You're nearly at the edge, now the outer rim of what JWST can see, and maybe what anyone will ever see. The telescope steadies itself in the darkness, its golden eyes open to the farthest possible past. What's out there isn't just old light. It's the beginning of everything. You hover with it, weightless, watching as the faintest flickers emerge from beyond 13.6 billion years ago, so dim that even the universe itself might not remember them clearly. Each photon, a survivor from the cosmic dawn, slips through JWST's mirrors like a secret finally told. The telescope is catching light from the first galaxies ever formed, from a universe barely 200 million years old, when space was smaller, denser, hotter, and filled with fog. That fog, made of neutral hydrogen, once swallowed light whole. But as the first stars ignited, their radiation carved out bubbles of transparency in the darkness, clearing the cosmic mist. Astronomers call this era reionization, the moment the universe literally became visible. JWST is mapping that awakening. It's seeing galaxies caught in the act of turning on the lights, of pushing back the darkness photon by photon. They're faint, reddish, almost shy, but they're there. Little islands of illumination in an infinite ocean of black. A mainstream fact, JWST recently confirmed galaxies at redshift 13, making them the oldest confirmed light sources humanity has ever seen. That's roughly 330 million years after the Big Bang blink in cosmic time. The fact that we can even perceive them feels like cheating the laws of nature. But as always, the universe keeps its mysteries layered. Scientists still argue whether these early glimmers are truly massive galaxies or small clusters magnified by gravitational lensing, made to look grander by warped space-time. Others whisper about primordial black hole seeds that might have formed directly from collapsing gas clouds before stars ever existed. JWST could be catching their shadows, hidden behind veils of starlight. A quirky tidbit slips in. One of JWST's early images showed a galaxy so unexpectedly bright and large that astronomers nicknamed it the Impossible Galaxy. It shouldn't exist that early. It breaks our models. Some joked that maybe JWST accidentally peered into a cosmic glitch universe debugging itself. And yet, there it is, stubbornly glowing. You find that oddly comforting. Even the cosmos doesn't always follow its own rules. JWST, floating alone at L2, keeps turning, its instruments cooled by shadow, its mirrors flawless in their silence. It doesn't just see backward, it connects everything forward. Every new discovery ripples through human curiosity, pulling tomorrow's thinkers toward deeper questions. You think of how all this started. A telescope made of gold, born from equations, sent into vacuum on a column of fire. A fragile thing built by fragile beings, meant to stare at eternity, the most human act imaginable. Reaching out into darkness, hoping something will answer. JWST has already reshaped astronomy. It's rewritten the timelines of galaxy formation, hinted at carbon in exoplanet atmospheres, even suggested that some star systems might be forming Earth-like worlds faster than we imagined. Somewhere in those distant spectra, perhaps, a faint signature of oxygen or methane waits a whisper of life. And maybe that's what makes this journey so dreamlike. You're not just gazing at galaxies, you're looking at the ingredients of your own existence, being cooked billions of years before you. Every atom in you, every thought, heartbeat, and sigh was once part of a star JWST could see. You can almost hear the universe exhale. The stars don't look back, but they share their stories anyway. You picture JWST as it really is now, suspended in an endless blue-black void. No sound, no motion, just light flowing in like a tide. Its gold mirrors catch each ancient photon and bend it toward us. A million-year-old message delivered to a little planet that still dreams. There's something deeply reassuring about that. The idea that even light this old can still arrive. That no matter how long it drifts, it can still find its way home. And maybe that's the quiet truth of JWST. It's not just showing us the universe's past. It's showing us the endurance of connection. Light endures. Curiosity endures. You endure. The cosmos stretches endlessly beyond. But here, in this small moment of calm, it feels close enough to touch. You breathe out slowly now, as if syncing with the telescope's gentle drift through its orbit. Your heartbeat steadies, like the pulse of distant stars fading into silence. Imagine the mirrors folding in the dark light, dimming, data streams slowing. The last photon of the night caught and catalogued. The hum of instruments fades to a low vibration, almost like a sigh. Out there, beyond the telescope's reach, the universe keeps expanding, stretching further into mystery. And yet, it's peaceful, like a tide rolling away, leaving starlight on the shore. You picture yourself floating beside JWST, eyes half closed, golden panels glinting faintly in the sunlight. You can almost feel the warmth of that glow on your face, soft as candlelight. Around you, infinity hums, a deep, wordless lullaby. It doesn't matter how far away the galaxies are. Tonight, they're close enough to dream about. Close enough to remind you that even in the vast cold, there's beauty, motion, and meaning. You've wandered across billions of years tonight through the first stars, the invisible webs of gravity, the very birth of light. And now, as everything grows still again, you realize that the silence isn't empty. It's full of echoes, of time, of endless possibilities waiting just beyond the next flicker. So rest, knowing that somewhere above, a golden eye still watches the cosmos breathe. Good night, dreamer. Let the stars keep their watch a while longer. Sweet dreams.